Hi everybody and welcome to Pajama Physics. If you haven't seen my other videos, that is where I mentioned pajama physics, but we are going to go over the dimensional analysis problems, but we are going to go over them in a different way. So maybe it might be a little bit easier for people to see what needs to be done. Okay, so I'm going to first start by scrolling down just a little bit so that we can get a better view of the screen. So how many miles will a person be running in a 10-kilometer race? So we always have to start with what we know, our absolute known. Okay, so we are given 10 kilometers. Okay, and so now let's draw in our dimensional analysis lines. Okay, I'm just going to grab a different color. So this is our starting, this is our ending, and this is going to be our conversion. Okay, so we were only given 10 kilometers. So I can just put a 1 down here. Why? Because 10 divided by 1 is still 10. Okay, so if you ever get confused where you should put another thing here, or I feel like I'm missing something, well, look back up at your units, and if you don't have a per something, or per second, or per feet, or something like that, then you can just leave it as is. Here, I'm only given 10 kilometers. That's all I'm given. Okay, so I can put a 1 right there. Why? Because 10 divided by 1 is 10. I was about to say 1. Whew. So conversion, I have to look up here at my conversion factors, and I have to choose something that is going to allow me to get miles in the end. Okay, I don't want anything here on the bottom. I just want miles up at top. Okay, so looking at my conversion factors here, I see this one. So I need to write it in such a way that my kilometers cancel out. So I'll just start with putting down my kilometers. Okay, and I know that I have to end up with miles, so there we go. So now I just put in my conversion factor. So I see that 1 kilometer equals 0.62, oops, sorry, 0.621 miles. So now I just do the math. So let me erase this one more time. Sorry about that. So now I just do the math across. So let me change this color. I'm just doing the math across. So across the numerator and then across the denominator. I'm just just doing it out right across. So I will change my color one more time. And I get 10 kilometers. Just kidding, because we canceled them out. So I get 10 times 0.621 miles. And then at the bottom here, all I get is 1. Why do I only get 1? Because my kilometers canceled with my kilometers. My miles are left, but that's at the top. So it's just 1 times 1, and that's equal to 1. Okay, so 10 times 0.621. So that is equal to 6.21 miles. Okay, let's look at another one. So the moon is 250,000 miles away. How many feet is it from Earth? So again, I start the same way with my dimensional analysis line. Okay, and I have to write down what I'm starting with. So 250,000 miles. Okay, so I know that I need to cancel out my miles. So I'll just put miles right down here. And I know that I need to get feet. I need to get feet right here. That's what I need to end with. So I have to look back up my conversion chart and I have to find something that has miles and that has feet. So I see that right here. 1 mile is equal to 5,280 feet. Okay, so now all I have to do is 250,000 times 5,280. What are my units? Well, my miles cancel with my miles, and all I have to do is do the math across. Okay, so I get 250,000 miles times 5,280. I'm going to let you do that math yourself. Okay, next page here. I'm going to do this one last example, and then I want you to keep working it on yourself. Again, I have so many videos on dimensional analysis. I think we should be okay if we figure out that these are just the dimensional analysis lines. And here we go. So again, we start with what we know. Our absolute known is 10,000 gallons. And we need to convert it into cubic meters or meters cubed. So that is our ending amount. So I know that I need gallons at the bottom here, and I need meters cubed up here. So 1 gallon, we're looking for gallons. We're looking for something that we can use. 1 gallon is equal to, come on, can't see it, hold on. All right, so 1 cubic meter or 1 meter cubed is equal to 264.2 gallons. And that conversion is right here. Ooh, it took me a long time to see it. So now I just do the math across. Okay, just do the math across, and I cancel out my units. So my gallons cancel with my gallons, which is great. It's exactly what we want. And so we're left with meters cubed. All right, so we just do the math across and we find out what we get at the end. So we get 10,000 gallons up at the top, or just 10,000 because we already canceled it out, and 264.2 at the bottom. So now just finishing out the math, 10,000 divided by 264.2. I'm going to let you figure that one out, okay? The average American student sits in class 330 minutes per day. How many hours per day is this? So we are fine with keeping per day, but I'll just show you how this looks on the dimensional analysis chart here. So we have 330 minutes per 1 day. So remember when I was saying if you hear per, just put it as a fraction in your dimensional analysis line. That is one of these examples, okay? So we are trying to get hours. So I know that I need something here to cancel out my minutes. Well, 60 minutes is equal to 1 hour. Awesome. So now we just cancel out my minutes, and I'm left with hours per day, which is exactly what we want. So yippee! And so now we just do the math across. Okay, so we get 330 times 1, and then we get 60 at the bottom times 1. Okay, so 330 divided by 60, and what is our unit? Hours per day. Now part 2 is asking you to do pretty much the same thing, but turn it into seconds per day. And then you have an additional question on top of that. I hope this helps you a little bit more to see what you need to do. Again, we have moved on to linear motion, so if you still don't understand it, that's okay. Just turn in what you have. I know that you are putting your best effort into this, so I will grade you accordingly, okay? Can't wait to see you all again. Bye.